Sirius is the brightest star in Earth's night sky with an apparent visual magnitude of -1.46. Typically, the only objects that outshine it are the Sun, the Moon, Jupiter, Venus, Mars, and sometimes Mercury. It's a binary star in the constellation Canis Major. For northern observers, Sirius dominates in the winter sky, and in the southern hemisphere, Sirius appears overhead in the evening in summer. Although Sirius is the brightest star, it's not the largest. It appears so bright because it's 25 times more luminous than the Sun and relatively close to Earth at just 8.6 light years away. It's the closest star that's both more massive and a lot more luminous than the Sun, and it's also the closest with a white dwarf companion. Let's take a closer look at the bright and brilliant Sirius. The Bayer designation for Sirius is Alpha Canis Majoris, highlighting it as the brightest star in the Canis Major constellation. Its more common name comes from a Greek word, Sirios, which I probably pronounced incorrectly, which means glowing, sparkling, or scorching. Very appropriate for such a bright and twinkly star. Sirius is also nicknamed the Dog Star because of the constellation that it's in, but it's not the only star known as such. Other stars in both Canis Major and Canis Minor are known as the Dog Star in various cultures. Interestingly, Sirius is sort of the origin of the expression dog days. The term refers to a period of time through July and August, the hottest part of the summer season, when Sirius rises in conjunction with the Sun. Ancient cultures believed that the combination of the Sun and Sirius was responsible for the extreme heat experienced during this time. This is, of course, a false assumption. Sirius is much too far away to affect Earth's temperature. Because it's so bright, Sirius has been observed by humans for thousands of years. It's present in astronomical records of the ancient Greeks and Polynesians. To the ancient Egyptians, it was known as Sothis, or the Nile star, and they based their calendar on when it was first visible in the eastern sky shortly before sunrise. It would return before the Nile River rose, sort of acting as an announcement of the coming floodwaters that would nourish the land. Among the ancient Romans, the hottest part of the year was associated with the heliacal rising of Sirius, giving rise to the aforementioned dog days. With advancements in technology and observation methods, more about Sirius has been learned in the past few centuries. In 1718, Edmund Halley discovered the proper motion of stars. This means that stars move across the sky with a predictable angular motion relative to more distant stars. However, in 1844, Friedrich Wilhelm Bessel published a scientific note describing how Sirius had been deviating from its predicted movement in the sky since at least 1755. Bessel hypothesized that an unseen companion affected the star's motion, and concluded that the pair revolved around each other in a period of about 50 years. And later, he turned out to be right. In 1862, Alvin Graham Clark, an American astronomer and telescope maker, confirmed Bessel's hypothesis. He spotted Sirius B, a small companion star, through a recently developed Great Refractor Telescope. Sirius B was the first object to be recognized as a white dwarf. A mystery still remains about Sirius, though. Some ancient records describe Sirius as red in color, but today it's white. Even stranger, there is currently no accepted explanation for this discrepancy. As mentioned before, Sirius is a binary star. The brightest component of this binary is Sirius A blue-white star about 25 times more luminous than the Sun. Its radius is about 1.7 times larger than the Sun's, and it has a surface temperature of around 9,940 Kelvin. Sirius A is a main sequence star of spectral type A, and it has about twice as much mass as the Sun. Sirius B, meanwhile, is a white dwarf, which means it's very tiny and therefore much fainter. It's only about 12,000 kilometers in diameter and 10,000 times fainter than its companion. Its mass is calculated at about 98% that of the Sun, and its surface temperature is about 25,000 degrees Celsius. Calculating the mass of Sirius B actually proved to be a huge challenge for astronomers. Usually, the mass of a star can be calculated based on its brightness or luminosity, but Sirius A's luminosity overpowered ground-based observations. This made it impossible to isolate the much dimmer luminosity coming from Sirius B. Then, in 2005, a team of astronomers assembled data from the Hubble Space Telescope, which finally enabled someone to calculate the mass of Sirius B. Sirius A and B revolve around each other every 50 years. Their orbits are highly eccentric, so the distance between them varies, but on average they're about 20 astronomical units apart. Sirius is the closest example of a binary system with a white dwarf, and this makes it valuable for studying stellar evolution, mass-luminosity relationships, and the cooling of white dwarfs. Its brightness also makes it useful for calibrating astronomical instruments and testing observational techniques. To our knowledge, there are no planets around either star in Sirius. Sirius might be the brightest star in our sky for now, but it sadly won't remain that way forever. Based on calculations from the ESA's Hipparcos satellite, Sirius will increase in brightness over the next 60,000 years as it grows closer to Earth. Eventually, though, the distance between Earth and Sirius will increase. The star will become fainter, but will still remain the brightest star in Earth's night sky for thousands of years. I wonder what will take its place when it's not the brightest anymore. I hope you enjoyed this little exploration of Sirius. I would really appreciate it if you could leave a like and a comment, and of course you can subscribe if you want to see more. Space videos are a little bit slow at the moment, and I've been very busy, but I'm gonna try and make them come out more frequently. Thank you very much for watching, have a good day, and I hope to see you next time.